I make my own cubes, my own design, and I prepare here a sheet of aluminum, and I have painted the template on a CAD program where I make some grooves with a diamond disc. I cut some grooves here where I can fold the whole thing in the shape of a cube, and I cut the holes here with a hole saw, and I decided to finish the cutting short before the tool cuts through the aluminum, where I am able to align the cones more properly, because I have to solder the whole thing, and I need a very tight fit for the solder not to leak through, and this is a bit of fiddling around, but I have here a seam, and this is very close, so I can fill that seam up with the solder. That's the idea. And the cube itself is arranged after I folded it. I put some plastic in as a layer, then a copper cone, again a plastic, and another cone. And I fix that with hot glue, and when you then measure with an instrument, you have an electrical potential of 600 millivolts. When it is grounded, you have to ground the casing, and I ground that with my body. I touch it. I touch the casing and measure the potential in between the casing and the inside or the surface of the copper cone, because that copper cone is electrically isolated from the casing. Now I am going to measure the electric potential on that device. This I still have to glue on the casing, so I choose another one. I choose this cone, and I set the voltmeter on direct current, auto range, and the casing is ground, and the copper cone is the electrical potential I will measure, or it is the other pole, and when I touch it with the other probe, nothing happens. The interaction starts when I ground the casing. And the voltage is rising slightly up to 60 millivolts. Sometimes more, sometimes less. Now we have 53. And when I touch the copper cone with the thumb of the same hand, I get another reading. I have here seen 3 peaks, like the cone setup that is like a capacitor, of course, would charge and discharge. I've seen that 3 times, and then it got a stable reading of 600 or 700 millivolts, a stable one. And you see it here on the voltmeter, and it's still raising a bit. And of of course one could say that's a measuring mistake because the multimeter has a high impedance and you cannot measure these potentials with that instrument. That could be true, but it indicates something. I will not really say that the measurement is reliable, but it indicates that the capacitors have a function in that device. Because what you have here, this is a capacitor, of course, a two-layered capacitor, and when you measure the capacitance of that, you get some reading here. That's not much, but it is capacitance, definitely. This one has even 40 picofarad, I think it is. And when I disconnect, it goes to 0 again, so it's definitely 40 picofarad. Now I go on direct current again, and what happens when I ground that device now on a real ground, because I used my body as ground. So I prepared here a wire, and I now connect that to the casing of the device, and I press here the casing towards that wire with the one probe. And you see already the value is raising because the device is grounded. And I don't touch the device. This is just ground, and the device seems to transmit some energy into ground so that it's flowing to the earth. So one can assume that here in the surrounding atmosphere there is some kind of energy that is collected by the 6 capacitors of the device, and it goes through the casing towards ground because the casing is grounded now. And I don't get any effects here from my hands when I put my hand near to the device. It doesn't affect that very much. And when I touch a cone, nothing happens. And when I measure a cone with the other probe, we have the same as before. When I touch it at the same time, the voltage is raising. And oops, because I don't have to touch now the device with the other hand because I have connected it to ground. So before my body was ground, and now it's the real ground, it's the earth. Just slipped off there. So I repeat. The voltage is raising. But not that much as before.